Hello everyone, my name is Ryanj Mansal and welcome to my ELL 101 project. My project is on tank circuit, also called a resonant circuit, LC circuit or a tuned circuit. Tank circuit is an electric circuit consisting of an inductor represented by the letter L and a capacitor represented by the letter C connected together. The circuit can act as an electrical resonator, an electrical analog of tuning fork, storing energy oscillating at the circuit's resonant frequency. Components and diagram of LC circuit. One of the main component of the LC circuit is the inductor and other is the capacitor. These are symbolically represented like this on the paper, and one may find like this in the laboratory. This is the circuit diagram showing how the inductor and the capacitor are connected in a tank circuit. Let me show you the animated diagram demonstrating what's happening in the LC circuit. A capacitor stores the energy in the electric field E between its plate depending on the voltage across it, and an inductor stores the energy in its magnetic field depending on the current through it. If an inductor is connected across a charged capacitor, the voltage across the capacitor will drive a current through the inductor, building up a magnetic field around it. The voltage across the capacitor falls to zero as the change is used up by the current flow. At this point, the energy stored in the coil's magnetic field induces a voltage across the coil. Because the inductor opposes the change in the current, this induced voltage causes a current to begin to recharge the capacitor with the voltage of the opposite polarity to its original charge. Applications of LC circuit. These circuits behave as electronic resonators, which are a key component in many applications like amplifiers, oscillators, filters, tuners, mixers, and many more. However, I was extremely keen in the use of the tank circuits in the radio receivers, which I will explain you in the coming slides. In the radio receivers, these LC circuits are used as filters. The radio waves from many transmitters pass through the air simultaneously without interfering with each other and are received by the antenna. These can be separated in the receiver because they have different frequencies, that is, the radio wave from each transmitter oscillates at a different rate. To separate out the desired radio signal, the bandpass filter allows the frequency of the desired radio transmission to pass through and blocks the signal of all other frequencies. The bandpass filter consists of one or more tank circuits or the tuned circuits. But you may think, where are these LC circuits and how are these circuits being used in the radio receivers? Actually, the LC circuits are used in the tuning process in the bandpass filter, which is present in the radio receivers. To select a particular station, the radio is tuned to the frequency of the desired transmitter. The radio has a dial or the digital display, as you can see in the figure, showing the frequency it is tuned to. Tuning is adjusting the frequency of the receiver's passband to the frequency of the desired radio transmitter. Turning the tuning knob changes the resonant frequency of the tuned circuit. When the resonant frequency is equal to the radio transmitter's frequency, the tuned circuit oscillates in sympathy, passing the signal on to the rest of the receiver. That is why the LC circuits are of the great importance. I hope you liked my work and thank you for viewing my project.